So function, let's say my w is equal to limiter of, so it has to take into several factors. So one factor is my w interface, w extrapolated, okay, and w cell and w neighbor. Okay, so basically I want to limit the extrapolated value to be it shouldn't be higher or lower than the cell at the value of the w at the cell or at the neighbor. So basically w has to be equal to w extrapolated and the w of w greater than w cell greater than the maximum over w cell, and the w neighbor is going to be set to the maximum. Okay, let me just say w max is equal to this, and w min is equal to min of this. So this is preventing any creation of new local minimum and the maximums. Is equal to w max. Okay, w less than w min is equal to w min of w less than w min. All right, so this basically limits the extrapolated w to the values that is permitted to create no new minimums or maximums. So here what I can do is, after I computed the values, where am I? Here. Okay, but before I call the Goodenough scheme, I should say WPL is equal to limiter of WPL. So for the WPL, let's actually do it before this. Let's do it after we extrapolate for left and right cell. So WR is equal to limiter of WR. So the cell value should be W, and the neighbor value for extrapolating towards the right should be the cell value at the right. Okay, so that is here. I can copy it from here. And WL should also be applied with the limiter, except for the neighbor value is on the left. Right? Okay. Now, for the third time, let's evaluate our scheme and plot the solution. Still have this. Wait, am I doing something wrong? This seems to be the same as this, right? First of all, let me see if I think I saved the file and limited this. Okay, did I pass in the right arguments? So, okay, so this is plus W at the right, W at the left. Yes?
I think in the indexing, if you go down to the limiter,
yes.
the indexing is either one something because it's greater than or equal to a boolean. So you're only effectively changing.
Yes, the index is a Boolean indexing, so I'm only changing the W that exceeds the that exceeds the value of W at the right. Let's just see if this is right by just calling one of these. So okay, so here W extrapolated is this, and let's step over. W is set to the same value as W extrapolated. Okay, W max is actually 100 by 1 array, which is what I should be. W min is also 100 by 1 array. So W greater than W max is going to be a value of a logical array. So it shouldn't do anything. So if I say W less than W max, what? Oh yeah, okay. Greater than W max should be an empty array, right? Less than W max is an array of everything, and W less than W min is also an empty array. So that's correct. So let's actually disable this and continue all the way to the end, and then let's say so basically we want to get to a point where we should see the limiter being active. So let's see if U prime is equal to U end. So UP let's see. So what is U? Oh, okay. So I should have this. So UP is a solution where I expect the limiter to be active at some point, right? And so then let's set the breakpoint again and use the UP to be an initial condition. So now let's step in, compute max and min. So now W greater than W max. Still, why is the case? Yes. In where? Okay. Line 13.
I'm not sure.
Yeah. So here I'm trying to say the value of the W at the I plus half interface, right? So on line 13, I think I'm right because if this is I plus half, this is I, and then the left value at the left interface is the right extrapolated value of the cell I. Yeah. Okay. So basically we are trying to figure out why is the limiter not active at some point.